Welcome to the Starlings One podcast. I'm Patrick. We have a big one today. This is a study about the usage of prediction markets for science reproducibility predicting. And the reason I say this is a big one is because it's from the Proceedings of the National Academy of Sciences, which is the second most cited journal in the world, or has been at one point recently. So I think this is a very reputable journal. I don't have a whole lot of notes. This is just a great study and a great source, that the fact that it was actually published in this journal. I just want to mention briefly the topic of the study and their methodology, so we can maybe think more precisely about what the implications might be. There's been a lot of talk, I think, or at least I've seen a lot of talk online about the potential for prediction markets to study science reproducibility. And this study from 2015, which is called Using Prediction Markets to Estimate the Reproducibility of Scientific Research by Anna Dreber et al. Its title is accurate, but its methodology was using the field of psychology and using a lot of psychology studies, looking at the titles of these studies and asking a group of experts within a prediction market to kind of guess whether the study would be reproducible. Now, the thing about psychology is, I don't want to rip on psychology as a field, but the journals within psychology tend to emphasize surprising studies. That this is something that's noted in this study that we're talking about today, the Prediction Markets for Science Reproducibility study. It mentions that psychology, perhaps compared to other fields, at least these journals, really emphasize surprising findings, which means there could be a little bit more chance for finding where studies that might sound exciting aren't going to reproduce because they're less likely, versus studies that might sound boring might be more likely to reproduce. If you use something more of a hard science, or you use something like math or physics, perhaps the incongruence could be a little more flat. Maybe there's just more room for variability within psychology because of the nature of what it is. So I think I just want to be very careful to mention that as you're listening to this, and as you think about science reproducibility using prediction markets as a tool. I wouldn't necessarily say that prediction markets are a great benchmark for everything generally, but they might have some excellent areas where they can be applied, and this definitely seems to be one of them. Again, we've linked the study. You should see it in the show notes, wherever you're listening to this from or watching this from. Other than that, like I said, no notes. Super interesting, fascinating study. Hope you enjoy. Oh, hey, and I almost forgot. Jump on over to starlings.one for more information. Check out all of our different socials. And you can also check out our completely open source and MIT licensed prediction market called Social Predict. If you just search Social Predict on GitHub, or just Google, or whatever way you want to find it online. You know how to find things. Just search Social Predict, prediction market. All right, great. Thanks. Enjoy the episode.
Ever get that feeling like when you read about some new scientific study, and you're like, this seems a little too good to be true?
Yeah, I know that feeling.
Well, good news. Today we are diving deep, really deep, into a paper that kind of gets at that, like, how much can we actually trust the science that, we read about, that we hear about?
Yeah, it's a really important question. I think at the core of a lot of this is this idea of replicability.
Yeah.
If a finding is really solid, you should be able to do the experiment again and get similar results. But turns out that is not always the case, especially in psychology. A lot of studies don't quite pass that test.
Oh, okay. So that's a little unsettling. So how do we know, which studies are actually going to hold up? Like, which ones can we actually trust? That's where this paper gets really interesting because they tried to figure that out. They used something called prediction markets to see if they could figure out which studies were likely to replicate even before anyone actually tried to replicate them.
Yeah. Think of it like scientists betting on which horse is going to win a race. But instead of horses, it's research studies.
Okay.
And they're basically betting on whether the results of a study will hold up when someone else tries to do it again.
So it's like gambling on the reliability of science.
Exactly.
I love it. But why use this whole market approach? Why not, I don't know, just ask experts or something?
Well, that's a great question. It's because markets can actually tap into this thing called the wisdom of the crowd.
Oh, okay.
It's this idea that a whole bunch of people together can actually often make better predictions than like any single expert would.
Interesting. Okay, so walk me through this. We've got this 2015 paper. It's from PNAS. That's the Proceedings of the National Academy of Sciences. And it describes this prediction market experiment. What did they actually do? Like, how did this work?
Yeah, so they got over 100 researchers together, and they gave them basically virtual money to buy and sell contracts that were tied to specific studies that were going to be replicated. And this was all part of this big project called the Reproducibility Project, psychology.
Wow, the Reproducibility Project. That sounds ambitious.
Yeah, it was huge. I mean, they set out to replicate 100 studies that have been published in some of the top psychology journals, just, as a way to try to see how reliable the findings really were. And as these replications were happening, our group of researchers, they were in the prediction market, placing their bets, trying to guess which ones would hold up.
Okay, so we've got this massive replication effort going on, and then we've got a bunch of scientists placing bets on the outcomes. So what happened? Like, were they good at predicting?
It's crazy. The market was actually surprisingly good at predicting which studies would replicate. Like, they correctly predicted the outcome of 71% of the replications.
Wow, 71%. That's way better than chance.
Way better than chance.
Okay, so this market, it's like it could sniff out the shaky science.
It seems that way. But here's the really cool part. It wasn't just about whether a study would replicate or not. The prediction market could actually give us some clues about the truth of the underlying claim, like the scientific hypothesis itself. That's where this gets, I think, really mind-blowing.
Okay, yeah. I mean, how could a betting market tell us about the truth of a scientific claim? I don't get it.
Right. To understand that, we need to talk about something called prior probability.
Prior probability.
Yeah. So think of it like this. Imagine, like, someone tells you they've got this magic coin, right?
Uh-huh.
And it always lands on heads. Like, what would your initial reaction be?
I'd be pretty skeptical, I think.
Exactly. And that's because your prior probability, like your initial belief that this coin actually exists, it's super low.
Right.
You've never seen anything like that before.
Yeah.
It goes against everything you know about how coins work.
Yeah.
But now imagine they flip the coin once and it lands on heads. Does that totally change your mind?
Maybe a little bit, but I'd still be pretty doubtful. I mean, one flip doesn't prove anything.
Exactly. Like, you need more evidence to really update your belief.
Right.
And that's kind of what this paper is getting at. The prior probability of a scientific hypothesis, like how much we believe it before we even do any experiments, it matters a lot.
Okay.
And what they found was kind of shocking, actually.
What did they find?
They found that the median prior probability, like the estimated likelihood that these hypotheses were true, before the initial studies even happened, it was only 9%.
Wait, only 9%?
15%.
That's incredibly low. What does that even mean?
It means that for a lot of these psychology studies, the scientific community, they didn't have a lot of faith in the ideas to begin with, even before they did the research.
So they were kind of starting off as long shots, like it was like betting on that magic coin.
Exactly.
Oh.
And it kind of raises these big questions about, what kind of research questions are we asking? What are we publishing in these top journals? Why are we studying things that most scientists don't even think are likely to be true in the first place?
I'm starting to see why this is such a big deal. So what happens to that prior probability, that 9%, once we factor in the results of the study and then the replication? What happens to those numbers?
Yeah, that's where it gets even more interesting, and we could talk about that right after this.
Okay, so that 9% prior probability, where does it go from there? How do the results of the studies and the replications actually change things?
Well, the paper, it actually has this great visual, figure 3, to kind of show us how this all works, how the probability of the hypothesis being true actually shifts as we have more evidence.
Okay, see figure 3, it's like a flowchart, right? And it shows these different probabilities, and they kind of change depending on like the results of the study and the replication. So walk me through it.
All right. So we're starting with that 9% prior probability, that initial level of, I'm not so sure about this. Then let's say the initial study, it finds support for the hypothesis. Bam. The probability jumps up to like 56%.
Whoa, okay, that's a pretty big jump.
It is. But here's the thing, right? 56%, that still means there's almost a 50-50 chance that the finding is just like a fluke. It's like flipping a coin.
Yeah.
Heads it's true, tails it's not. Not exactly rock-solid evidence.
Right, definitely not. So all those statistically significant results that, researchers love to talk about, that doesn't actually mean the hypothesis is true.
It's just a hint.
Yeah.
It suggests there might be something there, but it's not definitive proof. And that's where replication comes in. If that study is replicated successfully, then the probability it shoots way up to 98%.
Okay.
Now we're talking.
Right, so replication is like the ultimate confirmation.
Yeah.
It takes us from like coin flip odds to like, okay, we can actually trust this.
Exactly. But here's the other side of the coin, right? If the study fails to replicate, the probability, it plummets all the way back down, like 11%.
Oh, back to square one. All that excitement for nothing.
Yeah.
It really shows how important it is to replicate findings, especially the ones that, they seem really surprising, that kind of make headlines.
Yeah, I totally agree. But let's think about what this means for science overall, If the prior probabilities for so many studies are so low to begin with, does that mean we're just choosing the wrong things to research?
It makes you wonder if we're like chasing after these flashy findings, the ones that sound really novel or exciting, but maybe at the expense of solid, replicable science.
Yeah, it's possible.
Yeah.
And remember publication bias, Journals are more likely to publish studies that have these positive, exciting results. So we might just be getting a skewed picture of what's actually happening in research.
So we're only seeing like the winners, not all the studies that didn't actually find anything interesting.
Exactly. And it makes these unlikely hypotheses seem way more likely to be true than they actually are.
That's a mess.
Yeah, it's complicated. No easy answers. But, this paper, it does give us some interesting ideas, like, what if we use these prediction markets more formally in research?
Wait, really? So, like, scientists would actually be betting on research proposals?
Yeah. It might sound a little crazy, but it could be a way to get some healthy skepticism back into the system. Like, imagine if grant reviewers were using prediction markets, right? They could see how plausible the ideas are before deciding to give them money.
It's like a reality check for science funding. Instead of just chasing the most exciting proposals, we take a step back and say, hold on, is this even likely to be true?
Exactly. It could also help us decide which studies to replicate. Like, what if journals made researchers set up prediction markets along with their publications?
Oh, interesting.
That way, we could kind of crowdsource the assessment of replicability, see which findings really need a closer look.
So we don't just assume every published finding is true. We actually test it. It's like it adds this whole new level of accountability.
I think so. And that brings us to maybe the most important point from all this. We all need to get better at evaluating scientific information. We got to ask the right questions. Has this finding been replicated? What was the prior probability? What are the biases here?
So we're like, what, scientific detectives, carefully looking at the evidence before we just believe something? But isn't that asking a lot of people? Most of us, we're not scientists.
True. And it can seem kind of daunting, but it's not about being an expert in everything. It's just about having that healthy skepticism.
Yeah.
Think about it like you're buying a used car.
Okay.
You're not just going to buy the first one you see, right?
No way.
You can do your research, look it up online, maybe take it to a mechanic.
Yeah, definitely, yeah. You don't want to end up with a lemon.
Yeah.
So how does that, apply to science?
It's the same idea, right? When you see some big headline about, oh, this new study found this amazing thing, don't just take it at face value. Yeah. Dig a little deeper. Look for the replication studies.
Okay.
See if anyone else has been able to get the same result.
Right.
And think about those prior probabilities, too. Like, did this claim, did it even make sense to begin with?
So it's like checking the mileage and the accident history.
Exactly.
We want to know if this study has, been through the ringer and come out okay on the other side.
Exactly. And you could always get a second opinion, too. Read articles from different places,
Yeah.
See if anyone's, raising any red flags about the research.
It's like finding a trusted mechanic to give you the real scoop.
Right. And just like a car, even a study that looks perfect, it could still have problems.
Yeah.
And that's why it's so important to, think about the biases. Right. Who paid for this research?
Right.
Do they have, a reason to want a certain outcome?
Is the mechanic getting a kickback from the used car salesman?
Exactly. Oh, and another thing, science is always changing. What we think is true now it might not be true later,
Right, yeah.
as we get new evidence. So we got to stay curious,
Yeah.
and be open to changing our minds.
So never stop questioning, keep digging deeper. And it's not about rejecting everything or being cynical, right?
Right.
It's about being informed, really thinking about the information.
Yeah, being a good consumer of information.
This has been such a great deep dive, honestly. I
Yeah.
feel like now I have this whole new set of tools to actually understand scientific claims and figure out what's really going on.
That's great. And, if you're ever unsure about a study, you can always reach out to an expert, do your own research, keep asking those questions.
That's great advice. So listeners, next time you see a headline about, scientists discover this amazing, groundbreaking new thing, remember what we talked about today, okay? Be curious, be skeptical, put on your detective hats. And until next time, keep exploring, keep learning, keep asking questions. And as always, thanks for joining us for the deep dive.